We are working on the Connect 4 project from the Ybyte Python curriculum available at www.ybyte.in. Having developed the player code, the computer code, having developed now the game loop as well. In fact, we are now at the most interesting part of the project, which is the code to determine the winner. Now, this is quite interesting because this is where we really exercise indexing over a two-dimensional list, the list called board. Basically, there are four possibilities in which a victory can happen. Now, this victory could be by the player, by the computer, but the four ways remain the same. Horizontal, vertical, positive diagonal slope, negative diagonal slope. Now, let's first see what all this means with some examples. A horizontal victory would be something like this, where I have four coins coming in the same row. It could be red, it could be blue, but in this case, red is winning because there are four in a single row. A vertical victory would be four coming vertically, like in a single column. So that horizontal is in a single row, vertical is in a single column. A positive diagonal would be something like this. Notice here the four blue circles have come in a diagonal going upwards. So this is a positive slope. That's why I call it, say, diagonal 1 or say positive slope diagonal. Basically, these four are in a row now across that diagonal. Likewise, the negative diagonal slope would be four in a row along a negative going diagonal. So negative slope diagonal, you notice these four coins are in fact winning the game. Now, the way we will proceed is to write code to handle all of these four situations. In fact, there'll be a function for each of these. But there are, in fact, two interesting approaches in this regard. The first approach is, every time a move is played, I can check the entire board for any horizontal, vertical, or say diagonal winners. When I say diagonal, includes positive and negative slope. Basically, I can check the entire board for any kind of victory. Now, the other approach would be to check in a more focused area. This is possible because we know the row and the column of the last coin that has been played. However, we'll take the first approach, which is just to check the entire board. It's okay in this case because, the board is not that large really. However, clearly there's room to optimize in this code. Now, even though there are, let's say, these four different ways in which a player can win, when we write this code, we are going to take a much more unified view of it. The approach we'll follow is that in each of these situations, we will extract a list containing four values. For example, in case of horizontal winner, when we check for horizontal winner, we will extract a list of four values from a single row. For a vertical winner, four values from a single column. For diagonal winners, we will check again four values from diagonals. But nonetheless, in all cases, we'll end up with a list of four values. And we will write a separate function to tell us, well, look, does this constitute a winner? It does if all the values in this list are exactly the same. Now, now this will become more clear as we move further. But the point I want to highlight is that we will write six functions in all. One function to tell us if given a list, all the items in the list are exactly the same and equal to the given value. This will become like a base function, which will be called by all these four functions. So there will be one function each for each of these, because then we can focus on the indexing and call this function to do, let's say, the backend work for us. And finally, we will write a check winner function, which will put it all together and return to us, let's say, true or false. So from the gameplay point of view, check winner is the main function. I ask it to check if the player is one, with, let's say, value of 1, or if the computer is 1 with a value of 2, it returns me true or false. But internally, it goes and does all of this. Now, this approach I think is quite unifying, quite, let's say, modular, because this function can be used for other purposes as well later on. Now, I have seen other implementations where, let's say, this aspect of the code is also lumped with, let's say, these functions. But I think this is a cleaner approach because it makes it more modular. Now, next video onwards, we'll start building these functions. But I thought giving a big picture view, as always, helps because that tells us where we are going with this. I hope you found this interesting. In general, creating activities, applying ideas helps us to break problems down in smaller pieces, approach them one by one, and that's what we are doing at Ybyte. www.ybyte.in, because we learn Python programming through such fun activities. Take care. Thank you so much. Bye bye.